Hello dear students. In today's video, in project management in civil engineering or civil engineering project management, we will be looking into a problem, a numerical problem in which the crashing of network is being done. Okay, so what do you mean by crashing? Crashing means we will be reducing the time of completion of a project. Time of completion of a project. How we can reduce the time of completion of a project? Say, if suppose a project is supposed to be a plan to be completed in 10 days, okay, if all the conditions are ideal, we can complete it in 10 days. But due to some problems or issues, say for example a bad weather prediction is there, before that we have to finish it, then sometimes we may need to finish it in 8 days. Okay, the total project duration will be 8 days. That will be the maximum time we will be getting. So in this case, what you can do is you have to reduce the total duration by 2 days. How we can reduce it? By providing more laborers, more materials, more machinery, etc. Or in general, we can say by providing or supplying more resources, or utilizing more resources, we can reduce the time of completion of a project. Okay, so here we have in this problem, this is the problem statement is following table shows cost and duration of each activity. The indirect cost is rupees 3150, that is 3150 per week, and determine the optimum duration of project and minimum cost. That is the, so we have to find out the optimum duration and project duration of the project and the minimum cost of the project. That is the question. Okay, so in the question that in the table it is given that 5 activities are given, A, B, C, D, E. 5 activities are given, and for each of the activity the predecessors are also specified. For A and B there is no predecessors, that means A and B are the first activities, then C is following A, and D is following A, E is following B and C. Okay, then in addition to these two, we have 4 terms here: Tn, Cn, Tc, Cc. What are those terms? Tn is the normal time duration of an activity. So to complete activity A with the normal conditions, we need 7 weeks. We need 7 weeks. Okay, and like that, for B we need 9 days, and for C 5 days is needed, and D 6 days are needed, and E 6 days are needed. So these are the time duration of each activity for the activities to be completed in normal time with the ideal conditions or as per the planned conditions. Okay, but if due to some reason we have to we have to complete it earlier, then there should be some crash timing also. Okay, so A can be completed in 4 days also if we provide or supply more additional resources. Additional resource means there will be involvement of money also. Okay, so for completing this in 4 days, that is normally it will take 7 days, but if we supply additional resources, then we can complete it in 4 days. Then the crash cost will be 15,500. Okay, that means if you complete it in 4 days, it will cost 15,500 totally. Rupees 15,500 totally. For B, it can be finished in 6 days if you provide additional resources. Then it will cost 9,500. Similarly, for activity C, activity D, and activity E. Okay, so all those data are given. Then another one is Cn, the normal cost, that is if we complete the activity in 7 days, that is normally if we complete, or in normal time if it is being completed, then the cost will be 8,000 rupees for activity A. For activity B, it will be 5,000, and C it is 7,000, D it is 9,000, and E it is 6,000. Okay, so these are the data given. So Cn is the normal, this is normal cost, and this is the crash cost. So obviously Tn is the normal time duration and Tc is the crash time duration. Okay. So now we will find the optimum duration and minimum cost. Okay. Okay. So for that, first we have to draw the network diagram. How we can draw the network diagram? So starting from A and B, because A and B we have no predecessor, therefore we can start from the node 1, and A will draw A like this, and B like this. Okay, A and B, let nodes be 1, 2 and 3. Then for C, let this be A, this be B. For C, A is the predecessor. Okay, C, A is the predecessor, and another thing is for E also C is there. Okay, so for D also A is the predecessor. For D also A is the predecessor. So let us draw this D. This is D. Then for E, B and C is the predecessor. How can we draw that? B and C. So this is, let this be E. Okay, let this be E, and the C also should be a predecessor. Then how can C be added here? C should be C should follow A, and it should be the predecessor of E also. Therefore, we can draw it like this. This is C. This is C. So clear? This is C. Now the diagram is okay because C and C and B are predecessors of E, and A is the predecessor of C. Then A is the predecessor of D also here. You can see here. Okay. So A, B, C, D, E. 5 activities we have already drawn the network diagram. Now we have the time durations of each activity we will write here. That is, for A, the normal time is 7, and the crash time is 4. Okay. For D, the normal time is 6 and the crash time is 4. For B, the normal time is 9 and the other is 6. And for E, it is 6 and 4, and D and C also, it is 5 and 2. Okay, let this be node number 5. So node number 4. So this is the network diagram with all the activities, node numbers, and the normal time and the crash time. Okay, here. So I have drawn it more clearly. I have drawn this just to show you how to draw the network diagram and mark the activities and its corresponding durations and all. So here you can see the network diagram with the time of normal time and crash time being shown on each side of the each activity label. Okay. So here the total cost of the activity or the project will be, what will be the total cost? Sum of all these things. Sum of these will be giving you the total cost. What will be the total cost? 6,000 plus 9,000 plus 7,000 plus 5,000 plus 8,000. So that is equal to 35,000. The total cost will be 35,000. Okay, total cost will be 35,000 rupees. Here. Now what we are going to do is, we will be finding the critical path. Here, which will be the critical path in this one? So for that, we have to find out the longest path in the network diagram. Path 1 is AD. Okay, AD, and its corresponding project duration will be 7 plus 6, 13 weeks. 13 weeks. Okay, corresponding project duration is 13 weeks. Then second path is, which is second path? A, C and E. A, C, E, and its project duration will be 7 plus 5, 12 plus 6, 18 weeks. 18 weeks will be the project duration for the second path, that is A, C, E. A, C, E. And the third path will be, which is the third one? B, E. B, E. And its project duration will be 9 plus 6, 15. 9 plus 6, 6 is equal to 15. So out of these three paths, the longest one is second one, that is ACE, and the project duration is 18 weeks. Project duration equal to 18 weeks. Okay, so project duration is 18 weeks. Clear? Therefore, what will be the total cost? So step 1, total cost, say TC equal to, what will be the total cost? Total cost is equal to the total direct cost, that is 35,000 plus the indirect cost. The indirect cost is given as rupees 3150 per week. So how many week is there? 18 weeks. So the total cost will be 18 into 3150. Okay, so this will be equal to 35,000 plus 18 into 3150, equal to 91,700 rupees. 91,700 rupees will be the total cost. Okay, if the project is completed using the normal condition. So 91,700 will be the total cost of the project with a 18 weeks duration. Now we will start crashing. So for that, what we have to do is we have to find out another value, that is slope of each activity, slope S. Okay, so how to find out slope? To find out slope, we have the equation S is equal to CC minus CN divided by TN minus TC. This is the equation for calculating slope, crash slope for each activity. S is equal to CC minus CN divided by TN minus TC, where CC is the crash cost and the CN is the normal cost, and TN is the normal time duration for the activity, and TC is the crash time duration of the activity. Okay, so for A, what is the slope? What will be the slope? Tn minus Tc is 7 minus 4 is equal to 3. I will show you one example. Say Cc minus Cn. Cc is for activity A. So SA, slope for A is equal to 15,500 minus 8,000 divided by 7 minus 4. Okay, so this will be equal to 15,500 minus 8,000 will be 7,500. 7,500 divided by 3, and that is equal to 2,500. It will be 2,500 rupees. So slope of activity or crash slope of activity A is equal to 2,500 rupees. So it is 2,500 . 2,500, and for activity B it will be 9,500 minus 500 divided by 3, that is 4,500, and it will be 1,500. For activity A, so I have calculated the slope of each activity and I have shown it here. You can see here, these are the slope of each activity. For activity A, the slope crash slope is 2,500. For B it is 1,500, and C it is 1,000, and D it is 3,500, and E it is 3,000, using the same equation. Okay, so the total cost of the project is 91,700 rupees, and we have calculated the crash slope of all the activities, and it is shown in the table also. Okay, now we will start to crash. So crashing is okay. So another thing is we will be drawing the critical path like this. This is the critical path. This is the critical path, and the activities are A, C, and E. Okay. So when crashing, we have to select an activity which is in the critical path, because otherwise even if you reduce the time or duration of an activity, there will be no change in the completion time of the project. Okay, so you have to select an activity which is on the critical path, or a critical activity must be crashed. Okay, and another thing is, when we select the critical activities for crashing, the cost should be minimum. Cost of crashing must be minimum. That is, if we can reduce an activity's time duration by 1 week, we should be supplying materials and resources with the minimum cost involved, so that the total project cost will be an optimum cost. Okay, so we have to select an activity with the minimum crash slope. So now in this table, our activities are, that is, critical activities are A, C and E. Is it not? A, C and E. Okay, so out of these three, you have to select an activity for crashing which is having least crash slope. Okay, least crash slope. So in these three, that is A, C and E, the least crash slope activity is activity C. Okay, so we will be selecting activity C for crashing first. Activity C for crashing first. So activity C can be crashed by 3 days, because the bare minimum time required for completion of activity C is 2 and the normal time is 5. Therefore, the difference is 3 weeks. Therefore, we can crash it by 3 weeks we can crash. That is, we can reduce the time by 3 weeks. So the crashing can be done in single week also. That is, we will crash this activity for 1 week, then we will find the values, then we will continue with the next step as crash it by 1 more week, then do the same process, and another 1 more week we can crash. Then the normal time will be becoming 2 and or C will be, we will be writing it as C 2, 2 after crashing 3 times. So now this cannot be crashed because minimum 2 days is needed. Okay, there is no float or no slack is there, so there must be minimum 2 days is needed. Okay, below that it is not possible to complete that activity. So here what we are going to do is, we will be crashing it 3 weeks, crashing C by 3 weeks at a time. Okay, so the total project duration will be reduced by 3 weeks. Initially it was 18 weeks. Now the total project duration will be 15 days. So new project duration is equal to 15 weeks. Total project duration is 15 weeks. Okay. Now the new total cost equal to how much it will be? 35,000 plus what will be the other parameters, or we can write it in this way, that is using the cost we have already calculated, the previous total cost 91,700 minus, okay, initially it was 18 weeks and each week needs 3150 as the indirect cost per week. Now we have reduced it by 3 days. Okay, that means we can subtract 3 into 3150, because we need only, this is the total cost including or involving 18 weeks. Okay, So this includes the indirect cost for 18 weeks. Okay. So when we crashed activity C by 3 days, the total duration is reduced to 15 weeks. That means we need to calculate 15 weeks for the indirect cost also. Okay. So 15, that means, so we can subtract it from here, 3 into 3150. Okay. And one more thing we have to add here, that is the crash cost of or slope of the activity. That is 1000 is the crash slope. So we have it is per week. So we have to add 3 into 1000 also. 3 into 1000. Okay, so this will be the new total cost of the project when we crashed activity C by 3 days, and the total duration of the project also has reduced by 3 weeks, and that now the new project duration is 15 weeks. Okay, so 91700 minus 3 into 3150 plus 3 into 1000 equal to 85250. That is the new total cost, 85250. So the cost has reduced by crashing activity C. It is good for the company to reduce the cost. Okay. Now what happens? Now when we look at this, we can see that the total duration has, so this is 2, therefore the total duration of the path ACE is 7 plus 2 9 plus 6 15, isn't it? ACE has become 15. Path 2 has become 15 weeks. Then what about this path? This path has also become 15, isn't it? 9 plus 6 equal to 15. Path 3 also is 15 days, 15 weeks. Okay, so that is also a critical path. So this is also another path, that is, this is also a critical path, this is also a critical path now. Okay, because the path 2 and path 3 both are having total duration as 15 weeks. Now we have two paths. Once there is more than one path, one critical path in a network diagram after crashing or even before crashing, what we have to do is we have to crash either a common activity of this path, okay, or you have to crash both paths with the same say unit of time. That means if you are crashing say activity A by 2 days, okay, one of the activities of the other path also should be reduced by or crashed by 2 days, so that the total duration will be reduced. Otherwise, suppose if you are reducing one of the activities of path 2 by 2 days, the duration will become 13 days. Okay, so what will be the total project duration? It will be still 15 because this is the largest path. Okay, so when we crash a network diagram having two or more critical paths, then all the paths must be simultaneously crashed by the same time duration. Okay, by the same time duration. Clear? So here what we can do is as activity E is common, if you crash the activity E by any amount, any value, both these paths will be crashed by the same amount, isn't it? So we can select this one here. Okay, this is by chance, this it has come by chance. This E is a common activity, and if it is not common activity, you have to select an activity which is having least cost slope, crash cost, or least cost slope, that you have to select. Okay, so here we will crash E by, say, 3 days. 3 days. So no, you cannot do it 3 days. Only 2 days you can do, because 6 minus 4 is 2. So here E we will select, and we will crash it for 2 days. Okay. Then what will happen? So E is selected from here, and we will crash it. So new project duration is equal to, how much will be the project duration? It will be 13 days, 13 weeks, 13 weeks. Okay, so new project, total cost is equal to, new total cost is equal to, how much will be the total cost? The previous cost was 85250 minus how much was the reduction in indirect cost? 2 times 3150 plus what is the cost slope of E? 3000. Okay, how many weeks we reduced? 2. So 2 into 3000, and that will be equal to 85250 minus 2 into 3150 plus 2 into 3000 is equal to 84950. 84950 rupees. 84,950 is the new total cost of the project. Okay, so it has reduced from 85250 of the previous one. Okay, that means it has come down, and this will be the optimum value. Now we have to check, we have to try crashing another one. Now what happens? Now there are 3 critical paths. There are 3 critical paths. Why? Because this also has become a critical activity. How? You can see A is, normally it will take 7 days, and D takes 6 days. So 7 plus 6, 13. Then A, C, E will be again 13. Okay, and A and B, E also is 13, because 9 plus, what will be this value? It will be 4. 9 plus this also will be 4. So this will be 4. So 9 plus 4 is equal to 13. Therefore the first path also is 13, and second path is also 13, third is also 13. All the paths are having same project duration, time duration, and therefore all the 3 paths are critical paths. Okay, so if we reduce any of these paths or crash any of these activities, the same effect should be done on all the paths, or we have to find a common activity. Okay, so here what we can do is, A is a common activity for path 1 and path 2. Okay, so we will select A, which can be crashed, and we will select B also for path B and E. Okay, so we will select A because C we cannot crash. It's already being crashed to the maximum. So C we cannot crash. E also has been crashed to the maximum. Now only remaining is A. Okay, and D we will not be taking, because if you consider path A, D, we will not be taking D because its cost slope or crash slope is more, 3500. A only 2500 is there, so we will select this one, A, as the crashing activity. Okay, so we will select A and we will crash by 1 day. Okay, then for BE, B's cost slope is only 1500 and E's cost slope is 3000. So we will select 1500. That means B. We will select B also for the third path, critical path. Okay. So we'll crash this by 1. Therefore, the new project duration will be equal to how much? 12 days, 12 weeks. New project duration is 12 weeks. New total cost is equal to, it was 84,950 minus 1 day is reduced. So 1 into, or you can write 3150 indirect cost for 1 day plus what is the total cost, crash cost, 2500 plus 1500, or you can write 1 into 2500 plus 1 into 1500, or totally it is 4000, and this will be equal to, how much will be that? 84950 plus 4000 minus 3150 equal to 85800. 85800. Okay, 85,800 is the new cost, total cost of the project. Now you can see this is 84,950 and this is 85,800. That means the cost has increased. Okay, so when crashing, the variation will be like this. Okay, so here the variation, the cost will be minimum and this will be the optimum duration. This is time and this is in rupees, cost in rupees. Okay, so this will be the duration and this will be the cost, optimum cost and minimum duration. That means after this point it has increased. Okay, so this is the lowest point, 84,950 is the lowest point, or when we finish the project in 13 weeks we can get an optimum cost for the project to complete, because this one, when we crashed by 1 day, 1 week, it has, the cost has increased by some amount, isn't it? 85,800 is the new amount. Therefore we will consider 13 week as the optimum time and minimum cost, optimum cost and minimum time is 13 weeks and 84,950. Okay, so what we are doing is we will be first drawing the network diagram with the given data. Okay, then we will be finding out the project duration using the given normal activity time. Then we will be finding out the cost slope or crash slope of each activity using the equation Cc minus Cn divided by Tn minus Tc equal to S. Tn minus Tc is equal to S. Using this equation you will find these slopes. Okay, then from the critical path you will select a critical activity for which the cost slope is the least one, so that the project cost will be the minimum, In that way we will continue, and if there are more than one path we will be crashing the both paths simultaneously, selecting either a common activity, or if it is not available then we will crash each path by the same value, and then we will be finding out the new duration, then new total cost, using the cost slope, and it will be continued till the value increases, as we have shown in this graph. Okay, so this will be the, here it will be the minimum one. This is how we have to crash a project. Okay, thank you.